Chapter 6 is about the applications of integration. In the first section, we will have areas between curves. And this is not new, by the way. We have started also chapter 5 with areas. But now we will generalize the idea to any curves or even more than one or two curves. In 6.2, we will study volumes by using discs method, washers, slicing, and so on. And in 6.3, we will study the volumes by cylindrical shells. In 6.5, there is no 6.4, yeah, Hussein. 6.4 is about work, and you can study that one in any physics course. So 6.4 is not included. In 6.1, the first section in this chapter, we will study areas between curves. I think it is good to start by remembering what we have done at the beginning of chapter 5. If you remember, if we have a curve, let's say the graph of the function f of x, and we have here the x-axis, two vertical lines, x equals a, x equals b, and a is the area of this region. We have mentioned that the area here is exactly the definite integral of f from a to b. And this happens because here the function is positive. It is completely above the x-axis when x between a and b. If you can think about it here, indeed, we have here, it is like this, the integral from a to b, it is f of x minus 0 dx. What is this 0? It is here. This is y equal to 0. This is y equal to f of x. So it is just the upper curve. Let's call this one the upper curve. So let's call it y top, and this is y bottom. So the upper curve minus the lower curve. Okay, if you know who is upper, who is lower, you can of course integrate, and this will be exactly the area. You will guarantee that this will be positive because here f is greater than 0. And we will generalize the idea by taking the upper curve to be any function f and the lower to be a function g. How we did find it, by the way, if you remember, we just divide this into subintervals and then rectangles. We approximate the area of the rectangles. We get n goes to infinity, and we represent it as a Riemann sum. The limit of the Riemann sum is the definite integral. Now the question is, what about if the graph is not always above the x-axis? If the function is not always positive on this interval? So what about if it is sometimes like here? If it is sometimes positive, sometimes negative. Let's say this is a, this is a, this is b, this is b, this is a. Up to here, let's say there is a number here c. Here it is negative. The function here is below the x-axis, and here it is above. It is the same function, f of x. In this case, you should consider the idea that we mentioned when we divide, when we calculate the definite integral as area. Let's call this one a1, and this is a2. In this case, what will be the relationship between these two areas and the integral? The integral here will be what? The integral from a to b for f of x dx will be just what, ya shabab? Who can tell me?
a minus a2.
It will be a1 minus a2. And this minus, indeed, it means that here that the integral could be negative, could be positive, could be 0, but the area is always positive. I think I have mentioned this. We called this the net area. Okay. Indeed, our concern now will be about how to find the area. Now, how to find the area from here to here. So how to find the whole area, this one and this one together. In terms of integral, this is if you want to find the integral in terms of area. Now in this section, we need to find the areas in terms of integrals. So the idea in general, when we have a curve of a continuous function, of course, f of x over another graph g of x, and we have from the right and the left two vertical lines, x equals a, x equals b. This is the region that we want to find the area here. So the area is the region of the area of this region. How to find this area? We know how to find it if it is x-axis. So when it is y equals to 0, the idea is quite similar when you have y equals g of x, not necessarily the x-axis, any other curve. If you are sure that f is greater than g, if f is greater than g, if f here is the upper curve and g here is the lower curve, always from a to b, then the integral will be easy, just the integral of the upper curve minus the lower curve dx from a to b. That's it. Why this is happening? Of course, because the idea is coming, ya shabab, from the same idea. What you will do if you don't want to how to evaluate it, you will divide this region into rectangles, let's say n rectangles, and you will focus on one of them to call it, we will call it the typical rectangle. This typical rectangle, let's assume that what will be the width of this rectangle? It will be delta x, which is b minus a over n, if you remember, the length of the subinterval. And what will be the height? The height will be the distance from here up to here. If we, let's say that we choose the right end point, you can choose the right end point or the left end point and calculate the height there. So let's take any point. X star here means any point within this interval. It could be the right, the left, the midpoint, whatever. Now the length of this line or the height of the rectangle will be just, of course, the upper curve minus the lower curve. It will be f minus g, the distance from here to here. Now this will be the height of the rectangle and this will be the width. And what will be the area of the rectangle? The area of the rectangle will be just the width, this one, multiply the height multiplied by the width. And if this is for one rectangle, when you have n rectangles, you will have the summation. So this is the height, this is the width, and when you have n rectangles, you will have the sum of the area, the approximating. This is the Riemann sum. When you let n goes to infinity, when you have here so many rectangles, you will have this expression. And if you look at Shabab, what is this? This is the limit of the Riemann sum. And you know that the definite integral, we have defined the definite integral to be the limit of the Riemann sum. So what is this? Here it is. This is the integral. These two are the integral. And this one, f minus g, and delta x, it is here dx. So by the definition of the definite integral, we have the following. We have, if you have a region bounded above by f and below by g, and from the right and from the left by two vertical lines, x equals a and x equals b, then it is so easy that to find the integral, just f minus g integrate from a to b. But you have to be sure here that that f here is greater than g for all x in that closed interval. We will see the other case when we don't have this case. So this is the y top and the y bottom. So the top curve and the bottom curve, the upper curve and the lower curve. And of course, it is good to think about it like that, and also to draw a typical rectangle. Try that you have a rectangle here, and ask yourself what will be the width. What will be the width here? It is delta x, because you are on the x-axis. And here, of course, it will be the distance from here to here. It will be y top minus y bottom. And you will just, this integral, it is just like this. Is it clear, Shabab, how to find the area of a region that is bounded above by a specific curve and below by a specific curve? Let's take an example. And this is a straightforward example. Find the area of the region bounded above. So he mentioned for you what is the upper curve, and bounded below by this curve. So you know what is the lower curve, and bounded on the sides from the right and the left by two vertical lines, x equals 0 and x equals b. So here, if you remember, just to have an idea, it is important, ya Shabab, to sketch the graph. When you want to find the area, it is important to sketch the graph. Most of the questions they will be easy to be graphed. So you have to revise the graphing techniques. This is the exponential function, if you remember. This is y equals e to the power x. and another curve is what? Y equals x. Y equals x. This is y equals x. From where to where? From x equals 0 to x equals 1. This is x equals 0. This is x equals 0. And let's say this is x equals 1. So where is the region that we need to calculate the area for? The area, the region is here. It is this region. Now it is clear here, ya shabab, what is the upper curve? The upper curve is y equals e to the power x, and it is there, it is mentioned. So now who can tell me what will be the integral? The area will be the integral from where to where? We will integrate with respect to x. Why with respect to x? Because if you draw a typical rectangle, its width will be delta x, and its height, this is the width, its height will be what? The upper curve minus the lower curve. What is the lower curve?
X.
So this is what we have here, Shabab, is y top. What we have here is y bottom. So it is just y upper minus y lower. And from where to where? The region starts from where? Starts from 0. Up to where?
0 to 1.
Up to 1. Is always the upper curve stay the upper curve in this interval and the lower stay lower? Yes.
What do you
no
mean?
need to divide here or to split the integral into two integrals. That's it. Now you know how to find this integral. Now this is chapter 5. Halas, we will skip the details of the integration process because you know what is it. That's it. But make sure that your answer is positive at the end. If it is negative, it means that you did a mistake. And of course, it cannot be expected that this is 0. It cannot be 0, this area. It is, of course, some positive numbers. Any question, Shabab? Good. Let's go to the next example. Now here, it is not determined or it is not given in the question what is the upper curve and what is the lower curve. He just said, find the area of the region enclosed by the parabolas y equal x squared and y equals to x minus x squared. What we should do, how to start, ya shabab?
By graph.
Sketch.
I think it is the best thing to do here is to sketch the graph. And this is so easy. This is so easy to be sketched. The graph here, it is just like this. This is y equal x squared. Now for this one, I think I did this, graphed this one with you before, I'm sure. So it will be just y equals to what? Negative x squared minus 2x or plus. Just I reordered the terms and I will take negative as a common factor. So we will have x squared minus 2x. Now I will add the half of the square of the half of the coefficient of x, which is 1. Now this will be equals to what? Negative x minus 1 all squared. Negative times negative is positive. Here it is. Now you can sketch the graph. This is what I called the graphing techniques. To sketch a parabola, write it in the standard form. Now this is what? This is a parabola that opens down, and its vertex is what? 1 and 1. So here we are. This is 1, and this is what? 1. Let's say this is 1 and 1. Now it will opens down. What will be the x-intercept? If x is 0, we have x-intercept. And I think the another x-intercept is 2. 2 minus 1 is 1, negative it is 2. Because we did solve this before, ya shabab. Do you remember? This is 2. Now, where is the area enclosed? Enclosed, ya shabab, it means that it must be closed. It is completely closed. If you have a region, this is a region that is not closed. But you have something like here, something like this, this is closed. So it is enclosed by curves. Okay? Where it is?
From 0 to 1.
From 0 to 1.
0 to 1.
This one, is it this one?
Yes.
Or this one?
No, the upper one.
Good. So this is, ya shabab, the area enclosed by these two curves. I will solve this one with you when we have x-axis involved. So this is the region that we want to find the area for. This curve here, this curve, let me choose another color. So this one here, is the upper. So this is y top. And another one, let me choose another color. Let's say this one. This is the lower. We will call it y bottom, for example. Now, to find the area of this region, what we will do? It will be the integral, the area will be the integral from where to where?
From 0 to 1.
How can you sure, are you sure that this point is 1? How can you sure about it? Is it 1? Are you sure?
No.
Aha, so for 0, I think it is clear. For 0, it is clear. For this one, I'm not sure. So it will be y top minus y bottom. So in this case, we will integrate with respect to x or with respect to y, ya shabab. Draw a typical rectangle from the top to the bottom, and you can see that the width is delta x. So we will integrate with respect to x. Just think about the rectangle. The rectangle here, the typical rectangle, it has width delta x because it is vertical, and its height will be y top minus y bottom. So we will integrate with respect to x. Now, I think it is clear for us that y top is what? Who is the curve that is here upper? Is this one. What is this curve? It is y equals 2x minus x squared. So this is not difficult. So this is 2x minus x squared minus this curve, the green one. The green one here is what? Is x squared, dx. And we are sure that always, ya shabab, from the beginning until the end of the interval, what is upper, it is still upper. What is lower, it's still lower. Okay? So in this case, it is a matter of simplifying. So this will be 2x minus x squared minus x squared. It will be 2x minus 2x squared. You will integrate. Again, we're still looking for making sure that we are integrating from 0 to 1. It looks from 0 to 1, but how to make sure about that? You need to solve it to find the intersection points. In fact, this point here, it is an intersection point. So what do you have here? This is y and this is y. Both equate them. So just replace this y here by x squared. So you will have x squared equals to 2x minus x squared. Move this to there and you will have 2x squared minus 2x equals to 0. Divide both sides by 2 and take x as a common factor. You will have x minus 1. Am I right? You will
Yes.
divide both sides by 2, so you will have this. Then you will take x as a common factor. This is x equals 0 and x equals 1. These are the intersection points, this one and this one. So these are going to be my limits of integration. So you are right. It was from 0 to 1, and you are sure now, sure about it. You know how to find this integral. No need to spend more time, ya shabab, on finding the integral. The main target here is to understand the process of calculating the area. Here we are. Any question, ya shabab? Now let me ask you a question. Since you are not asking, let me ask. Yes.
I have a question.
Yes, please. Go ahead.
Should I draw the
Yes.
equations, or there is no
Answer is
need?
Yes.
Okay,
طبعاً,
then
why
how,
it is important, ya shabab? Why sometimes it might be clear and you can work algebraically, but it is risky. You may make mistakes. Okay, let me, for example, assume here that you didn't graph. How can you know which graph is upper, which graph is lower? You have this one, and you have y equals to 2x minus x squared. Now, when you integrate with respect to x, you need to know from where to where. You can equate them, and you can find the integral from 0 to 1, for example. Now, the question is, are you going to do it this way? Are you going to start with this minus this? Or this one minus this one? طبعا, one way to do that is to choose a number between 0 and 1. Some students, they are doing this. They say, let me, for example, take a half. Okay, and I will put it here. If I put here a half, what I will get, and if I put a half here, what I will get. Okay. So if I got here, for example, here we will get 1/4, and here you will get what? 2 times a half minus 1/4. So you will have 1 minus 1/4. You will have 3/4. Clearly that this is greater than this one. So I will choose this. This will be the upper minus the lower. But who can guarantee for you that the situation will stay like that? The upper will stay upper forever and it will stay there like that. No, it might do something like this. This is 0, this is 1. So this, the another curve, it looks like this. So here it might be the upper, but here it could be the lower. There is a possibility that there is a number in between. We will see that in the next slide, Sheikh Bab. So you will not be sure, 100% sure about which graph is upper, which graph is lower, without graphing.
Okay, and when I always draw, I assume that the graph is from 0 to 1.
No, I didn't say that. No, I sketched the graph of x squared. Here it is. And I sketched the graph of the another one. And then I did find x intercepts. X equals 0 and x equals 1. I obtained them from the intersection process or from the graph, of course. But here it was clear. This point, it was clear from the graph. But this one, it wasn't. We did solve these two equations to find what is x. It should be understood, ya shabab. Now, let me ask you this question. What about if I add here and I will add here and let me just add it here and the x-axis. How the question now will be? If we add the x-axis, what we will have? Where will be the region, ya shabab? If we add the x-axis, just if we add to this question the x-axis, where will be the region? Is it going to be this one?
No.
No, it is not.
It's included with the...
No, it is not included.
Oh.
You need to look at, this is the x-axis. This is the graph of this one. This is the graph of the another one. So where is the region that is included by all of them? Here it is, this one. This is the region, the yellow one.
Without
this is not. Now make sure that it is closed. Is it closed? It is closed. Is it bounded by these three curves? Yes, this one here, this one, that one here, and this one here. Now this is the area. Now the question is how to find the area of this region. We will see this later, ya shabab, when we integrate with respect to y. طبعا you can integrate here with respect to x, by the way. It is not a difficult one to integrate with respect to x. You need to do what? You will integrate from 0 to where? To here. What is this point, ya shabab? It is 2. Do you remember from the graph of this one? It was y equals to negative x minus 1 all squared plus 1. And when x is 2, you have x-intercept. So you will integrate from 0 to 2. But the problem here, that from here to here, up to here, it is 1. From here to here, look who is upper, who is lower. But after 1, look who is upper, who is lower. So here you will integrate. If you want to find this area of the yellow region, you will say the integral is, the area is the integral from 0 to 2, for the absolute value of what and what, you don't know. So you will divide it into 2 regions. This is the first region. So it will be the integral from 0 to 1. For this one is the upper. What is it? X squared minus the lower here is 0, the x-axis. And this is the x plus the integral from 1 to 2. Who is upper? It is 2x minus x squared minus the lower, which is 0, dx. This is one way. There is a better way to integrate it with respect to y. I will leave it for you, Shabab. طبعا it will be, we'll study this later in the next slide. To integrate this with respect to y, what you need to do, to look at the curve here to the right. Look at the curve here to the right. What is it? And write it as a function of x. So we will have it when we integrate with respect to y. We need to find what is x to the right minus x to the left, and then integrate with respect to y. and you will integrate from y equals what to y equals what. We will see that. Of course, here we will integrate from 0 to 1. I ask you, ya shabab, please redo this after studying what we are going to show you now in the next slides. Is it this one? I wish. No. Here, before that, we need to mention the idea that I told you about. What we did until now is when you have a curve that is always above and another curve that is always below. What about if we have two curves, they interchange. Here, this is F, this is G. Here, this is G, this is F. Here, it is the opposite. This is F, this is G. So let's say that this is C, this is D. Now the area here, if you want to find the area, in fact, the area will be the integral from A to C. If you say that the integral is from A to B, F minus G, you are wrong. This will be wrong. What you should do is to write the process like this. From A to B, the integral, you should write it with absolute value. And we will see why. It will be the integral from A to C plus the integral from C to D plus the integral from from D to B. From A to C, F minus G. From C to D, G minus F. The upper minus the lower. I'm still working on the same idea. From D to D, from D to B, it is F minus G. In fact, what is this? All of these, if you look at them, they are the absolute value. The absolute value of F minus G here, it is F minus G. Here it is G minus F. Here it is F minus G. Because you know, if you don't know if F is greater than G or G greater than F, or they are interchanging each other, then you need to consider the absolute value here. You need to consider where F is greater than G and where G is greater than F. In general, now we have the general definition of the area in terms of integrals. If you have a region bounded by two curves, F and G, and from A to B, then its area is the absolute value of F minus G. Be careful, it is not the same as the absolute value of the integral. The absolute value of the integral, ya shabab, is not equals to the integral of the absolute value. So be careful about this. They are not the same here, okay? Because here you will calculate the integral and then take the absolute value. No, here you need to consider the absolute value, then integrate. So in general, this is the definition of the area. And how to work, just remember that F minus G, and inside the absolute value, it could be F minus G or G minus F. It depends on which one is upper, which one is lower. And also you need to consider that you need to split the area into integrals corresponding to the areas, to A1, A2, A3, and so on. Yes?
Can we use this rule with the previous question?
Yes, exactly. This is what we did here. Yes.
So no need for drawing.
How can you know which one is upper, which one is lower? It's still the same problem. How can you know which one is greater? The question here, which one is it, less than or greater than? Which one is bigger, which one is lower? Ya shabab, don't be afraid from graphs. You have to sketch the graph of basic functions. You have studied that in 001 and 002, Math 101. You know how to sketch the graphs. And we will not give you difficult graphs. Usually they are polynomials, square roots, absolute values, parabolas, lines. It is not difficult at all. It is, of course, to avoid any mistake and to be sure it is important to sketch the graph of sine and cosine, for example, here. It is, if you know how to sketch the graph of sine and cosine, this will be very easy for you. This is the graph of cosine, if you remember. This is the graph of sine. Now here you have, you need to integrate the region bounded by these two curves from 0 to pi. This is 0, and this is here pi over 2. I think this one is pi, this is pi over 2, when cosine is 0. Now here it is, this is the right, from the right, So this is the region. Here it is. I think it is much clearer here. If you don't know how to sketch the graph of sine and cosine, so what you know? Now, it is important, طبعا this is given for you. So the right and the left vertical lines, they are given. So the area here, indeed, it is the integral. If you write that, by the way, the integral from 0 to pi over 2 for the absolute value, dx. But if you write it without absolute value, this is wrong. Which one you will write? Is it going to be cosine minus sine or sine minus cosine? You don't know. So this is why it is important, if you want to write it as an integral, write it this way. Now it doesn't matter if you write it cosine x minus x or cosine minus sine. When they are inside the absolute value, it is the same. Now you need to consider dividing this interval into two integrals. You will do this as from 0 to, and you can see clearly from the graph that here cosine here is the upper and sine is the lower. Here is the opposite. Sine is the upper, this is the lower. So it will be from 0 to pi over 4 plus the integral. So here the branch point is pi over 4. Up to where? Up to pi over 2. And this, of course, here, who is upper? Cosine x minus sine x dx. And here it is sine x minus cosine x dx. Now you can find these integrals. It's so easy. Okay. Now let's say you don't know what is this point. Assume that when you sketch the graph, you were not able to find what is this point. It is not difficult. Just equate them. Both sine x equals to cosine x. Sine x equals cosine x, and remember that x here, it is between 0 and pi over 2. So this means that x equals what? What is the x between 0 and pi over 2 for which sine x equals to cosine x? Clearly, it is pi over 4. Yes, you wanted to ask?
No, this is clear now.
Okay, now I think, Shabab, this is a good example about being careful when you, of course, integrate. Again, if I add here and the x-axis, for example, where will be the region? This is a question for you.
In the middle.
Yes,
Yeah.
it will be in the middle. If we add that one, if we add that choice, then the area will be this area here, because x-axis will be involved, and you, of course, you need to do it also as two integrals. Here it will be the integral here will be. I need to choose another color. This is not suitable at all. So now the integral here will be, or the area will be the integral from 0 to pi over 4 for what? What is this curve? Sine x minus the lower curve is 0 plus the integral from pi over 4 until pi over 2 for the graph here is cosine x minus 0, which is of course cosine. No need to write that, just dx. Okay. Now let me ask you something. Do you notice, Shabab, something that about area 1 and area 2?
They are
Equivalent.
similar.
They are equal to each other because of because of the nature of the graphs of sine and cosine. So indeed, if you calculate the integral here, you can do it as we mentioned before, from 0 to pi over 4, then from pi over 4 to pi over 2. And this is easy to be calculated, but here you need to spend some time to calculate. It is also not that difficult. If you notice, the value of this is the same as the value of this. And of course, this is the final answer. You could save some time if you just notice that the areas are the same. So you will just calculate, for example, A1, calculate just A1 from 0 to pi over 4, and then multiply by 2. Does this mean, Shabab, that this function here is even? Is this function even here? It is not.
Oh,
It is not. It is not even. So this is not about even. Don't mix up between this and the even functions. This is, of course, because of the equality of the areas. That area is the same as the area of that region, not because of the property of even odd function. Some regions are best treated by regarding x as a function of y. So usually we write y as a function of x. For some regions, it is better to consider x as a function of y. Let's say x equals g of y. As we see, for example, in this one, if you have this one, if you have a region bounded by the curve x equals f of x equals g of y between c and d, where f here is greater than g. When we are talking about y values, who is bigger will be on the right, who is lower will be on the left. So this is why it is important to call them x right and x left. So this one, it is x right, and this one is x left. And in this case, you will integrate with respect to y, because if you draw a rectangle, a typical rectangle, from the right to the left, the width of this rectangle will be delta y, and the length will be xr minus x left. Here it is mentioned here. And the area of this rectangle will be just xr minus xl delta y. This is for one integral, for one rectangle. For all of them, you will do it from C to D. Look, y start from C up to D. And you will make it as an integral. The area will be here, the integral. D instead of delta y, just write dy. Here it is. And of course, the same idea. If you are sure that who is to the right, who is to the left, you can do that. If you are not sure, take absolute value and consider to split the integral into two integrals or three integrals and so on, according to what you have. This is an example about that. Find the area enclosed by this line and this parabola. What is not good about this parabola here, Shabab, that y is not clearly a function of x. So here you should consider integrating with respect to y. So here, if you look here, you have x equals to y plus 1. Here, what do we have? We have what here? We have here, it is mentioned here. This is x, this is x. So here, solve this equation for x. You will have 2x equals to y squared minus 6, then divide by 2. You will have this one. Now, to find the intersection points, you need to equate them. Both x that is here, both it here. So both this equal to this. And if you did that, you will solve it. What you will have? You will have 2y plus 2 equals to y squared minus 6. Move these to the other side. So you will have y squared minus 2y minus 8 equals to 0. Factor. This is y minus 4 times y plus 2. So here y is 4 and y is negative 2. So you will integrate with respect to y, if you want to integrate with respect to y, from negative 2 to 4. And of course, you can find the x values. This is y, and this will be the corresponding x, and this is the corresponding x. Look, if you put here x equals to 4, you will have, of course, y equals to, if you put y equals to 4, you will have x equals to 5. Now the question is, who is to the right? What is x right? What is x left? Now, what is the curve to the right and the curve to the left? You need to decide, is it this one or this one? Which one of them is x to the right? Which one is x to the left? Again, sometimes you may say, let me take, for example, 0. From negative 2 to 4, let me take 0. For example, if you put here 0, you will have 1. If you put here 0, you will have negative 3. So it looks like this one is the upper, the right one, and this one is the left. But who can guarantee for you that this will stay always from negative 2 to 4? You need, of course, to make sure about that. So it is good to sketch the graph. And this is a line, and this is a parabola. It is not difficult to sketch both of them. You remember, Shabab, how to sketch the parabola when you write it in the standard form. Here, in this case, y is squared. So in this case, you have y minus h all squared equals to 4b, if you remember, for k, usually k they call it, 4bx minus h. This is the standard form of the sketching the graphs of parabolas. And of course, this one is open to the right or to the left, because the coefficient here is positive, it will open to the right. And of course, you need to find the vertex of this one. And to find the vertex, you need to complete the square for y until for y until you find the vertex. So if you sketch the graph, this is the line, and it is not difficult to sketch this line, and also not difficult to sketch this one, this graph. So here it is, this is the vertex, by the way, I did this sketch this with the previous class, and we found that it is -3. This is -3, the vertex here at x equals -3. You will have 0. When x clearly when x is -3, it will be 0. Now, this is not easy to be integrated, ya shabab, with respect to x. I will show you that in the next slide. But it will be easy to be integrated with respect to y. Why it is easy to be integrated with respect to y? Because here you have a curve that is on the right, here it is. And you have a curve on the left. And it is only one curve for the, always on the right, one curve is always on the left. So this one is x right, this is x left, and you will integrate from here to here. What is this value? Y equals to -2 until here, the upper point here, which is y equals to 4. So simply, this integral will be just the integral from -2 to 4. This here, it is y value. This is the curve to the right minus the curve to the left. And this will guarantee that I will have a positive number. And of course, dy now, integrate with respect to y. And here we are. It is not difficult for you to integrate. I will skip this, the calculation of integration. Look here, if you try it, ya shabab, to remember the curves that we have, they were y equals x minus 1. And the another one, it was y squared equals to 2x plus 6. Now, if you want to integrate with respect to x, and unfortunately, most of you, they like to integrate with respect to x, but sometimes it is possible, sometimes it is difficult. And it is not practical. It will involve more calculations. Integrating with respect to y is much easier here. Look here, this is y, clearly it is x minus 1. But here y, if you solve it for y, you will have two graphs, positive or negative, square root of 2x plus 6. Here, if you want to integrate with respect to x, you need to find this point, which is the vertex, by the way. You need to put this equals to 0, and here it is. And look here, if you want to integrate, who is upper, who is lower? The upper here is the positive curve, here is the negative curve. And up to here, up to where, what is this? This is, ya shabab, -1. X here is -1. So up to -1, from 0. So the integral now, if you want to calculate the area, it will be the integral from -3 to -1 for this minus this. This minus this will be the double of them. Let me write it here. It will be the square root of 2x plus 6 minus, it will be plus. So you will have two of them, dx. Plus the integral now from -1 to where this is upper, this is lower, upper, the same. So from -1 up to where, what is this point? What is x here? It is 5. To 5 for the upper, which is this one, minus the lower, which is this one. Now you can integrate. But look, the calculations here are much involved, ya shabab. The integrating with respect to y is much easier. Just look at the previous slide. Is that clear, ya shabab? The integral, if you want to simplify it, it will be like this: dx plus the integral from -1 to 5, square root of 2x plus 6 minus x plus 1 dx. So integrate with respect to y if you have a region that is clear to the right and to the left. This is the summary, ya shabab. This is the more general idea. When you have, of course, this is the area in general. Also here, if you want to generalize it, make it also here absolute value, because you may have a graph like this. Sometimes this one is on the right, this one on the left. I think it will be better to have more exercises. And we have here, ya shabab, some solved exercises. I've added them for you to have an idea about them. It is important to solve them and practice by solving them. This is an interesting one. Even this one, ya shabab, you can sketch the graph of this one. It is not difficult. Even if it is a polynomial, just factor it, and you will see the zeros. You will see the end behavior, where it is above, across the x-axis, or not across the x-axis. And this is, of course, also another example about which one is better, integrating with respect to y here, or is integrating with respect to x. Here you have the integral with respect to x, and you have to do it with two integrals, look, because the upper and the lower curve are not the same. But if you integrate it with respect to y, it will be very easy and very one integral only. You will calculate one integral only. And here the areas are given. This is also another important about how they can change the behavior. Look here. You cannot say it is always one of the upper. Here you need to do it as 3 integrals from -2 to 0, then from 0 to, I don't know what is this, maybe 2, and from here to 3. And there are 6 exercises with the final answers for you to practice. Let's go now to the old exam questions. I think we still have time to solve one of them. Now, who can tell me, please, ya shabab, read this one. What do you think? Is it easier to solve this for x or for y? To integrate. You have x equals -y squared, y equals x minus 4, y equals -1, y equals 2. So what you will do, you will sketch the graph. Okay, let's say this is x equals -y squared. This is a parabola that opens to the right. Do you know that? So let's say this is, here it is. It is this one. Okay, this is y equals, or x equals -y squared. Are you still, ya shabab, with me? Now, how to sketch it? This is a line. When x is 0, it is -4. So let's say this one, this is -4, and this is 4. So we have this line. I'd like to draw it with x-intercepts like this. So let me say that this is -4, this is 4. Okay. Now, what else? Y equals -1. So y equals -1 is this one. We need a graph that is like this. This is y equals -4. This is y equals -1, and y equals 2. Let's say this is y equals 2. Now this extend the line. Now, where is the region that we want to find the area of? Now, to find the area, what we need to do is to look at this curve and this curve. The 4. We have 4 graphs here. So the region, shabab, in my opinion, it is this one. Do you agree with me or not? Sorry, this is not included. So this will be the region that is from here, above y equals 2, and from the right is this one, and from the left is this one, up to where? Up to x equals -1. I missed that graph. Where it is? Here it is. Y equals -1. This is y equals to -1. Oh, it is there. It is there. It is still there. So here it is. This is the graph that we have. This is the area. The area is this one. I need a highlighter, but with yellow, because I need to change the color. So this is the region that we want to calculate the area for. And it is not easy to do that with respect to y, to x, but it is so easy if you wanted to do it with respect to what? To y. Now, this is, ya shabab, the curve that is here. What is it? What is this curve? It is x equals to y plus 4. So this is x right. And this curve here, it is the curve on the left. What is this curve? It is x equals -y squared. So it is x left. Now the integral, the area will be just the integral from where to where? Y starts from where? From -1 up to where? Up to 2. For x right minus x left. dy, we will integrate with respect to y. Now this will be the integral from -1 to 2. The curve to the right, it is y plus 4. Minus the curve to the left is -5. So it will be minus, it will be plus. Y squared dy. I will keep the calculations for you, and you can find the integral easily. Okay. طبعا you can also integrate this function with respect to y, but it will be with respect to x, but the calculations will be more calculations than this one. This is much easier. And I wish that we have time for this. I did solve this one with the previous section, but let me solve it with you, shabab, in 1 minute or 2 minutes. The class طبعا time is up. If you want to leave, you can leave. طبعا this is important because you have also here 2 parabolas and x between 0 and 3. It is not difficult to sketch the graph of here. If you look, what is this, shabab? It is a parabola with vertex at 1 and 2. So here it is. It is opens up. For this one, it opens down, and the vertex is what? 1 and 1. So it is, let's say this is 2, this is 1. So it will opens down. Let's say like this. It is, of course, when x is 1, it is 0. It will be 0. So now this is, let's say this is 3. Means from 0, this is 0 up to 3. So let's say this is 3. And I'd like to draw this again to have intersection point like this. And let me also enlarge this like this. Now, where is the region that is enclosed by these two curves? Here it is.
Between them.
Here it is. From 0 to 3. This is the region that you want to calculate. طبعا there is no intersection points. Oh, this is not true, ya shabab. The last part is not included. Just let me here, started from here and here it is. This is the region. Now, how to write this as an integral? This is now the most important part. To find this area as an integral, it will be the integral from where? From 0 to 3. Who is upper? This one. Okay, this is the graph of this one, and this is the graph of the another one. So it will be x minus 1 all squared plus 2 minus the another one, negative x minus 1 all squared plus 1. All of this integrate with respect to x. Don't try to find intersection points because there is no intersection point between these two graphs. There are many ya shabab, so many old exam questions. Practice by solving them, please, especially the ones that they are not solved. There are many solved ones, but also there are some old exams without solution. This is all what we have for today, inshallah. Tomorrow, inshallah, we will practice by solving the recitation of this